Hi Year 11s, welcome back to the second video in this series on applications of geometric sequences. Hopefully you've had a good break over lunch. I have not taken a break and I'm just going straight into the next video as I record this the night before Friday. And I understand that this is quite a heavy lesson. So as I said at the end of the last video, I'm happy to give some time next week if needed to catch up on this. Our goal in this exercise and in this video is to apply geometric sequences to depreciation. And the name that we're going to give to this geometric method is reducing balance depreciation. We don't have to worry about distinctions between yearly and less than yearly time intervals, so you should find the questions in this video simpler. And the video is going to be shorter as well. So without further ado, let's get going. So first, I'd like you to recall some definitions that we made in the previous class when we defined flat rate depreciation. So this is a word that you probably haven't seen until this class, unless you have spent some time in a business or economics class. So just by way of reminder, an asset is something that is used to make money. It might also include property and equipment. So for example, in the school, chairs and tables are assets. The building is an asset. The projector is an asset. Depreciation refers to a reduction in the value of that asset. So for example, the school might buy a nice table for you to sit on. The table might cost $200, but after it's been worn out, sat on, chewing gum scraped off and all that, it's not going to be worth $200 in 10 or 15 years' time. Depreciation is a way that people in the real world capture the fact that things aren't worth as much after they've been used. Flat rate depreciation, which we introduced in a previous class, is a method which involves depreciating by the same amount each time period, based on a percentage of the initial value of the asset. This should sound quite similar to simple interest. The interest payment is based on a percentage of the initial amount in the account. You should think of flat rate depreciation and simple interest as very close cousins. So for your benefit, when you're looking at the notes, I'll just say this is similar to simple interest. Except that with simple interest, the value is going up. With depreciation, the value is going down. So that's an important difference that you need to keep in mind. Now, flat rate depreciation is modeled with an arithmetic sequence. So I'll write this down here as well. Flat rate, we use the arithmetic sequence. For the other one, reducing balance, we are going to use a geometric sequence. Okay, so what's the difference between flat rate depreciation and reducing balance depreciation, which we're introducing today? So with reducing balance depreciation, what's happening is we are depreciating by the same percentage. Which means the amount of depreciation is recalculated each time period. And as you're listening to this, you should hear echoes of compound interest, where the interest payments were recalculated each time period. So just as I said in the first video, when you're learning this for the first time, it's very easy to use the wrong sequence. If you're doing flat rate depreciation, you should use an arithmetic sequence. If you're doing reducing balance depreciation, you should use a geometric sequence. Therefore, in all of today's exercises related to depreciation, you should be using a geometric sequence. All right. I've just got two examples. So in this first example, I'm going to do the same thing that I did when we compared simple interest and compound interest. So here's an example. Suppose I buy a computer for $1,000 and I depreciate it by 10% per year, once per year. If I were to use the flat rate depreciation method, I would first start by finding 10% of 1,000, and that's 100. So every year, I will reduce the value of the computer by 100, like so. However, with reducing balance depreciation, I recalculate this 10% every year. So this time, I'm going to multiply by 0.9 each time. And a very interesting thing happens. When I use the reducing balance depreciation method, my value is actually higher compared to flat rate depreciation. And that's because as my value gets smaller, when I depreciate by the same percentage, that depreciation amount gets smaller. So first I take away 100, then I take away 90, then I take away 81, and then I take away 72.9. Notice that that amount that's being taken away, it's getting smaller. So if you're the owner of the asset and you want to sell it off to someone, flat rate depreciation seems a bit harsher. You're going to sell it off for less money, whereas reducing balance depreciation kind of gives you a higher estimate for the value of your asset. You might still choose to use the flat rate depreciation method. It's up to you, really. But we're not going to be too focused on which one to use. We're just going to tell you which one to use in the question, and then we'll ask you to do some calculations. So let me quickly recap percentages again. So again, you wrote this down in Thursday's class before we went off for school photos. But if you've forgotten, to decrease a number by r%, what we want to do is multiply by the factor 1 minus r divided by 100. So, for example, suppose we started with the number 80 and we wanted to decrease it by 15%. The calculation that we would do would be 80 times a bracket 1 minus 15 divided by 100. And that's the same as 80 times 0.85. And I'm actually having a mind blank, so I'm just going to use a calculator here. $80 times 0.85, 68. Okay. When we do depreciation using the reducing balance method, we're going to construct capital R using this expression. So let's do an example. Suppose we buy a car for $30,000. So a brand new car, sort of a car sort of on the cheaper side, and we're going to depreciate it by 25% every year, once per year. The reason why I'm writing it once per year is so that it's unambiguous. Because if I don't write this last sentence, you might ask me, do we depreciate it every month, every week, every year? If I don't tell you, you can assume it's every year. Okay. Let Vn be the value of the car after n years. Part A asks for a recurrence relation. So, because we are using flat rate depreciation, and I should actually say this in the question, so I should say its value is depreciated by 25% per annum using, the reducing balance method. Not the flat rate method, that's the other one. Today we're using the reducing balance method, which will use a geometric sequence. So, our recurrence relation needs two parts. First, we need an equation defining the value of the car at the start, and that's 30,000. Next, we need another equation defining how we get the next number in the sequence from the previous sequence. Some number r times Vn. Now here, the depreciation rate is 25%, so I can define lowercase r to be 25. And my common ratio, capital R, is going to be 1 minus r divided by 100. This formula is just an application of decreasing by r%, which I showed on the previous page. So in this case, it's going to be 1 minus 25 divided by 100, which is 0.75. So my recurrence relation is going to be V0 equals 30,000 and Vn plus 1 equals 0.75 times Vn. And now we've done the hard work, because now we can do some calculations with this recurrence relation. So part B asks us to find the value of the car after 10 years. So first we'll write down a formula. Vn equals 30,000 times 0.75 to the power of n. It actually doesn't matter which order you write these numbers in, because when you multiply numbers, order doesn't matter. It's just that I've put r to the power of n first in all of our examples, so I want to keep it consistent. So if I know that, now I can substitute n equals 10. So it's going to be 0.75 to the power of 10 times 30,000. And if I do that, we will get the following. $1,689.4054. And that's approximately $1,689 to the nearest dollar. So it's not worth much. But that's because it's losing a quarter of its value, 25% every year. You might think this depreciation rate is too high, so you might choose a different rate and get a different answer. And that's totally fine. Okay, part C. How much does the value of the car depreciate in 10 years? If you don't like the word depreciate, just think of the word reduce. How much does the value of the car reduce in 10 years? And if I frame it like that, it should be clear that what we want to do is find 30,000 minus 1,689. And this time, it's V0 minus V10, rather than V10 minus V0, because I want to start with the bigger number and take away the smaller number. So V0 minus V10, gives us 30,000 minus 1689. And if we do this calculation, we get 28,311 to the nearest dollar. So, with depreciation, you just need to use this formula. We don't need to worry about P because we will always consider depreciation over a yearly time interval in this study. If we're not going to, if it's not, it'll be really, really, really clear, and all you need to do is divide R by how many times it's done in a year. But I'll tell you if one of those questions is coming on an assessment, because I've never seen anything sub-yearly in a depreciation context in this subject. All right, so that's it for exercise 3H. I reckon you've had a really big day today with 2 large videos on compound interest and reducing balance depreciation. I do apologize once again that I wasn't there, but I hope this video is enough to get you going. So what I would like you to do now is go back to wherever you are up to. You might still be on compound interest. If you want to write notes, please do that at home. Use class time to do questions. And I would like you to complete as much of 3H as you can by next Wednesday. If you can't complete it, that's fine, but I would like you to help yourself. You can seek help by looking at the textbook, and you can contact me as well. Remember, as I said at the start of the year, I would rather be contacted too much rather than not often enough. So if you have to send me messages several times a day over the next few days, that's fine. All right, thanks everyone, and I look forward to seeing you all again next Wednesday.